So the next thing I want to do is create a storage that will encrypt the password as it is being saved to the database and decrypt it when it's being written from the database. This is very useful for data that you want to keep encrypted in the database or change between wherever and whenever. The idea here again is that you can separate the way it's stored from the way you refer to it in your code. So the first thing I need to do is learn how to encrypt and decrypt data. So I created this basic class over here. It's very, very basic. I made it static. I said here that it has the user method instance to use. It defines the keys that it will use to encrypt. Then when it gets a string, it will convert it to bytes. It will cipher it, and it will convert it to base64 string. That's the way to store encrypted data in the database. You have to use base64, otherwise you'll have lots of problems. And the other way around, I'm going to take the value, read it from base64, decipher it, and return it. Let's see that it works. I'm going to go to the program. I'm going to say var p equals demo encryptor dot encrypt to base64 my password. And I'm going to say var r equals demo encryptor decrypt from base64 of p. And hopefully this will work. We'll be able to see that p is encrypted and unreadable, whereas r represents something that we can read. Great. So now let's use that to encrypt our password. So if I'm going to go back to my entity, we can see here that in the text column, when I say storage, it's accepting something of type I-column storage strategy text. And if you remember previously we looked at string bool storage, we could see that it's I-column strategy bool. Okay, so the storage refers or regards the actual data type that one needs to use in memory. Great, so let's do that. Let's go to our code and add a new item of code. We'll call it encrypted storage and encrypted text storage so we can better relate to it. And we can say here that the text storage is of type I-column storage strategy of text. Perfect. Let's light the light bulb and add the usings that we need, and then the light bulb again to implement the interface. Great, created two methods for us. So let's start very simple. Yeah, text should be using Firefly box text. Let's start very simple and say var dbval equals loader get string. Yes, and return dbval. And save, we're going to say here if value is null, saver.save null, else saver.save string. We're going to give it the value. I'm not going to care about the length right now, so I'm going to say 100 and fixed width false. And let's build it. Expected sys. Yes, okay, so we're going to say here new demo.encrypted text storage. Perfect. So we've defined our class over here, and we've set it in our entity as the storage we want to use for our password. Now, obviously, we didn't encrypt anything yet. We just want to play with it. So let's run our code. And I'm going to put a breakpoint in the load and another breakpoint in the save. And let's see what happens. So I'm going to go to the table. I'm loading the data from the database, so it's going to get to the load method. And I can see here dbval. Great. And it's going to save it for all sorts of reasons. So I'm going to see here, I'm saving 1, 2, 3, 4. Perfect. Again, reading. And if I'll change the 1, 2, 3, 4 to something else, again, it's going to read it from the database. 1, 2, 3, 4, 5. And I'm about to save it. We can see that it's saved. Perfect. So this is cool and fun. But now let's add the encryption to it. So instead of returning the dbval, I'm going to call our encryptor and say decrypt from base64 the dbval. And instead of saving the actual value, I'm going to say, well, encryptor.save or encrypt to base64 the value. Let's run this now. Okay. Now I'm going to get an error because the existing value doesn't match something that can be encrypted or decrypted. So I'm just going to do here and say, well, try and just return blank. Perfect. I've got this error because the values that I had in the database weren't matching encryption properly. Great. Let's run this. So now I have Noam without any password. Let's go ahead and edit. 1, 2, 3, 4. And I've got this nice little error, which means that I'm sending a data which is too long for the database. So this is a good time to introduce streaming into our algorithm. So let's say here, stream n. Great. This is how you know this is real code. So now I'm going to change the password to 1, 2, 3, 4 and create another row. Great. And when I look at this data in the database, we can see this garbage over here which nobody can read. But when I look at it from the application itself, it looks like readable data. And this is the beauty of storage. I can use storage to separate the way the data is stored in the database from the way it appears in memory, for the way I use it in my application. So I can store any data type. I can store number or strings or anything else, encrypted, decrypted, and replace them. As long as I can get some kind of symmetrical translation, it would work. Now, one last word of caution. Obviously, when you do this, you might need to be aware that the database column should be bigger. As you've seen here, the base 64 string is bigger than the original 30 chars that I've allowed for the password. So you might need to make bigger columns. And also, sorting greater than, less than, obviously will not work so well because the database values are different than the ones that appears in memory. I hope you make good use of it. Enjoy!